Here we have some properties of exponents. This is just a quick worksheet where you can just kind of work out some of these quick problems. I will attach these in the worksheet module, and this one is just called the property of exponents. So here we have two terms or two items where we have the same exact variable, we have their coefficients, and then of course we have the exponents of your variables. So when we go to tackle these, this multiplication or this property of exponents is that when it comes to your values, we're actually going to be multiplying these values. So 2 times 2 will give us 4. And then when it comes to your exponents, while we see multiplication between your two bases, because keep in mind, anytime you have your base, we can call this a to the b. A is considered your base, and b is your exponent. So while your bases are being multiplied, we are actually going to add together your exponents. So 2 plus 3 is 5. So we actually have simplified is 4m to the 5th power. Now, what happens when we have a negative value, a negative exponent? We are not able to have negative exponents. So when this results, we can actually subtract the two together. That is, if we are combining these exponents. So once again, we are multiplying their numerical values. And when we put your r's together while your bases are being multiplied, we're actually combining your exponents through addition. And in this case, because you have minus 3, we are actually going to subtract 2 from 3. So this gives us negative 1. So while it looks like we have the two values having come together now as 8r to the negative 1st power, we are not able to have negative exponents. So in this case, if you have a to the negative 1st power, for example, we have to transition this to then go below this division sign. You can say this is now 1 over a to the 1st power, now positive. So wherever it is located, if that value is located in the numerator, it then drops down into the denominator. Now, any other value besides it will remain in its location. So in our case, 8 has a degree of 1, this one being positive. So it gets to stay in the numerator, whereas this r has a negative exponent to drop it below the division sign. So if we were to rewrite it, we have 8 over r to the 1st power. We're going to try it again with this one. Something very similar. So again, multiplying your two numerical values together, you get 8. Bringing together your variables. Again, your bases are being multiplied, which suggests we can combine your exponents through addition. Now, in this case, you could say plus a negative 3, or you can just say 4 minus 3 for 1. So we can bring those together, 8n. And now because it is a positive 1 as your exponent, we can leave it alone in its position. If we were to do, again, the value up here, your coefficient of this first one is 1. If you don't see it, it's always 1. So 1 times 2 is just 2. M to the 4th times m to the negative 3rd. Again, adding those values together. We're combining. We now have 2m. Now we might mix it up and you might see multiple values or multiple negative exponents. Now before you begin, I mean, we can certainly bring your values together. 3 times x minus 1, x to negative 3, y to the 3rd. So combining your values as we've done before, 3 minus 1 is equal to 2. And then you have y negative 3 plus 3. So while this is going to provide us with a 0, it does not mean that y is now zeroed out, which means that this whole thing is equal to 0. Instead, this is going to be a placeholder value. This whole item is equal to 1. So 4x to the 2 times 1, or 4x squared. Now, the idea behind that is that if you have a to the 0 times a, and I'm going to write this in a different color, a to the 0 times a to the m, or a to the b, we'll say. When we go to add them, we have a 0 plus b, which means a to the b. So the only way that would be possible, or be made possible, is if your value here is just 1. So 1 times a to the b. I'm going to see if there are any more. Let's see. Oh, let's try that skill again. So anything raised to the 0 power, we now know is equal to 1. So a to the 0 is equal to 1. Now, when we have something like this, instead of going ahead and distributing your negative exponent to your monomial term, monomial meaning one singular term, we don't have any addition and subtraction. Instead, let's tackle this negative exponent and turn it positive. The only way we can do that is if we bring this whole term and we switch its position. Instead of being in the numerator, we're going to drop it below in the denominator. So that just means that it comes down below the division sign and it now turns positive. In its place, because there's a coefficient out here of 1, we can just keep that in its place. Then we can go ahead and distribute your exponent evenly throughout the expression. Now, when you distribute it throughout the expression, we are doing, not only do you do it to your numerical term, 2 to the 4th, but you also are going to be multiplying your exponents. If you have a to the b times c, or to the c, then you're going to be multiplying b times c. So in our case, we're going to multiply 2 times 4 to get 8. So your final answer is 1 over 16x to the 8. So anytime a power is now being raised to another power, we're going to multiply those exponents. So let's try that scale one more time. So this one is a positive exponent here. So it does not need to change positions, but we do need to make sure that it goes throughout our expression. A to the 3 times 2 equals 6. So we have, 16 a to the 6th power. And one more time, dealing with a negative exponent. So we see a negative exponent, we're going to change its position. So we're going to drop this below the division sign. 4xy to the positive 1, and its place is the coefficient or whatever values are remaining. And in our case, because now it's just a degree of 1, we can go ahead and either drop the parentheses or keep them because it won't change this problem. So I'm going to zoom out, and that is going to just be it for our values here. Just kind of covering some of these different values. For those that are more trickier like this one, I would say move their positions first and then start to combine. So for example, on this one, looking at the values that have a negative exponent, we notice that j here has a negative exponent, so that one can automatically come down. So when we go to rewrite it, we have 2h3k to the 4th over 3j j to the third k. Now these two j's are being multiplied together. They are next to each other, so they can combine through addition. So we still have 2h cubed. We're going to leave k alone for a second. 3j to the fourth. Now let's take a look at these k's. This is the first time we're seeing a k above as well as below. Now, unlike what we do when they're next to each other, like these j's, we can add their exponents. We can do that because it's being multiplied. So the opposite of multiplication being division means that we're going to actually get to subtract these two exponents. So what we can do with k is say k to the fourth minus this 1k to give us 3. Now, kind of the math behind that, if you have 4 k's above here and 1 below it, because they're being multiplied above, there's no addition signs, and you have 1 singular, 1 below, we get to cancel them out, and you'll see you have the 3 remaining k's. So your final final answer should be this. Let's try it one more time with the 1 below it. So again, let's mix up these positions. You have a negative exponent here, so that's going to drop. Again, we're dropping. And now this is the first time we're seeing an exponent that is negative in the bottom. So we are going to bring it up top. Now you notice that all other ones have a positive exponent, or if it's 0, we know that these values are actually going to be 1s. So when we go to rewrite it, we have 3x to the third. We've moved up x to the fourth, and it's now positive. We have also moved down the y to the first and the z to the first. The ones with the exponents of 0 are just 1, so we can leave them alone. Combining those exponents through addition. And there you go. I believe that should be it. We'll just do one more. 25 isn't so bad. If you were to try and subtract them to begin with, like this one, we would have 3m to the negative 4 minus 3, which will give you an even bigger negative value. So you have 3m to the negative 7. If your value is negative, then we're going to drop that whole item down. 3 still having that positive exponent gets to stay, m to the 7th. So this is one way you can do it. If you do not move m to the fourth down, you can still subtract these two values. It'll just make them a little more negative. You can also put it down and add. All right, that is going to be it for today as far as these properties of exponents. I will quickly show the answer key in case you have worked these out or if you're pausing along and going through. And there's a second page.